Hi, today we're going to look at polynomial functions and their general graphs. So if you can refer back to my intro to polynomials video, we talk about types of polynomials, giving them different kind of names, degrees of polynomials, and then naming them by degree, standard form, stuff like that. So we're now going to use all that information and see what the graphs look like and how they all relate to each other. So these are going to be general graphs, not necessarily parent functions. Um, the general graph here is going to tell us, the graph is going to show us what kind of degree we have for the problem, the maximum number of possible solutions, also known as roots or zeros. You'll hear all three words interchangeably. And those are where the graph crosses the x-axis. And then we can see what the number of turns of this graph actually does, what that tells us. So let's let's see what happens. So I've got this first problem. F of x equals, I'm gonna just put a number there, like the number 2. That number 2, whenever you see y equals or f of x equals 2, remember all these f of x's, just y equals. That 2 is not going to change. It stays constant. So we can call it a constant. We can name it. That constant term also has a degree. The degree it goes along with the exponent of your variable. We don't have any variables here, so we call this a degree 0. All right, now what does the graph look like? Well, a constant term never changes. It always stays that number. So for us, we're going to have this horizontal line going side by side. It will always be 2. So y equals 2, that line going side by side. Okay, let's look under it. So f of x equals x, or y equals x. Pretend this says y equals mx plus b. Y equals mx plus b is a line. And in this case, if you see something with a degree 1, we call that linear. And I just said, degree goes with the exponent. So here we didn't necessarily have an exponent, but if you don't see something, there's always this magic 1 there, degree 1. That general form of that graph will look something like that. You got a line in that positive, with that positive slope going on it. Okay, moving up. Anything with an exponent of 2 we call a quadratic. And that has a degree of 2. So what does that look like? Well, we've got this parabola. All right, and let's look at one more. So this graph might be new for us. Anything with a degree 3 we call cubic. Exponent is 3, so degree 3. Now this graph looks like that. So let's stop here and kind of talk about what we got going on. So parabola, that U shape goes up and out. So it's growing very quickly. It's kind of moving outwards very slowly. Something similar is happening here. So down here, we're off to the left. We're going to go down very quickly, but we're going to move out very, very slowly. Similar and opposite, we're going to go up very quickly and move to this right very, very slowly. Okay. Solution. So we didn't really talk about solutions yet. Does this blue line cross that axis, the x-axis? No, no solutions there. Does this blue line cross this axis? Yes, one possible solution. Okay. Our parabola here. We could possibly cross this x-axis in 2 spots, giving us 2 solutions. Down here, we've got 1, 2, 3 possible solutions. Okay, so every time you cross the x-axis, that's a solution. Solution, a root, a 0, all mean the same stuff. Okay, how about the number of turns? Well, look at this. We've got 1 turn, 2 turns with an exponent of 3. Here we have 1 turn with an exponent of 2. Here there's no terms with an exponent of 1. So if I have 2 turns, it has an exponent of 3, so it goes up by 1. If I have 1 turn, exponent goes up to 2. I have no turns, I go from 0 to 1. Okay, so there is a relationship there. So what does that tell us about exponent of 4? Well, I know my name. I know with an exponent of 4, it's going to be quartic. I know with an exponent of 4, that's going to be degree 4. I'm going to take a guess because my number of solutions matches up with the degree. I'm going to kind of take a guess and say 4 solutions or 4 zeros. Now, what about the graph? Well, if I know that I have 2 turns with an exponent of 3, 1 turn, exponent of 2, if I have exponent of 4, that means I have to have 3 turns. One, two, three. There's your 3 turns. There's what your graph, your general form of that graph will look like. All right, exponent of 5, we know should be a quintic. We know exponent of 5 means degree 5. Our number of solutions, 1, 2, 3, 4. They match up with our degree. So if I have degree 5, I should have 5 solutions. And now the graph, if I have a degree 5, 5 solutions, I should have one less turn. So I should have 4 turns. One, two, three, 4 turns. There's a general form of that graph. Now, one last thing. Let's kind of, before I get to these guys, take a look at these two. Your general form in that positive x squared, that positive x to the 4th, we have a positive graph. They both arrows point up. They open upwards. How about with my odd exponents, 1, 3, 5? If I were to kind of like zoom out and look at this in the big picture, my first graph, has that positive slope. What about this one? If I were just to look at the arrows, aren't they just kind of doing the same thing, going in that same direction? When I get an exponent of 5, if I kind of skip all those little waves, isn't my graph still moving in that positive slope type of way? That's always going to happen with your positive graphs here. So with all of that, can we predict what's going to happen with an exponent of 6? Well, with an exponent of 2 and a 4, both our graphs opened up. This graph has to open up. So we went from 1, 2, 3 turns with an exponent of 4. I have an exponent of 6. I need 5 turns. 1, 2, 3, 4, 5 turns. Okay, anything with a 6 degree, we usually just call it to the 6 degree polynomial. So that also tells us the degree 6. Number of solutions, 1, 2, 3, 4, 5, 6. How many times do you cross the x-axis? And 5 turns. Okay, so something with a 7, well, we're now going to have 6 turns. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 turns. We again call this 7th degree polynomial. Degree 7. 7 possible solutions, and we had 6 turns there. This is just the basics of what these polynomial functions can look like, their graphs can look like. You may see different versions of these kind of being up and down on the different little hills. And then all of these are in the positive form, so all of your positive graphs will look like this. One of my later videos, I'll see what happens if you do happen to have a negative up there. That's general graphs of polynomial functions.